All right, this is Honors Algebra 2 Pre-Calc, and we are doing 5.4 in Pre-Calc, which is sum and difference formulae. So it's important that you be able to use these formulae, but it's not super duper important that you memorize them. They can be useful. I have the sine and cosine ones memorized. I have not ever bothered to memorize the tangent ones, so let me walk you through the sine and cosine sum and difference formulas. So it's called sum and difference because it's either u plus v, which would be a sum, or u minus v. When my brain sees the sine one, my brain says sine, cos, sine, keep the sine. Meaning it's sine of the first angle, u, cosine of the second angle, v, cosine of u, sine of v, and then keep the sign. If it was a plus, it's still a plus. If it's a minus, it's a minus. Cosine of u plus or minus v, my brain says cos, sine, change the sign. And in my brain, it makes sense that I have to change the sign on this one because this one seems like the simpler formula, right? Because it's cos, sine, I don't have to think about the order. So for the tangent one, honestly, I just put the sine on top of the cosine if I have to in a pinch, but you can certainly memorize this one as well. You can see that, again, it's u and v in order for the angles, and then the plus and minus on the top means that the sign stays the same, and the minus on the plus on the bottom means that the sign is reversed. So let's walk through. So we're going to find the exact value of both of these expressions. Note that they are not the same value. So this is sine of u minus v, right? It's also sine, so it's worth noting that this is also sine of 105 degrees, but that's not on the unit circle, so we can't find the exact value. We'd only be able to find an approximation in the calculator, and that's not what we were asked to do, right? We were asked to find the exact value. So we could find an approximation of this value with the calculator, but we weren't asked to find an approximate value, we were asked to find the exact value. So I'm going to use that formula, right? So it's going to be sine, cos, sine, and make sure that when you do these, you write the degree symbol. I know it's annoying, but if you write just a 30, then what you're implying is that you mean radians, and then keep the sign. So all of these things are on the unit circle, right? 30 is right here on the unit circle. Sorry, I kind of missed, but 30 is right here, right, at the point root 3 over 2 comma 1/2. Right, and 135 is right here at the point negative root 2 over 2 comma root 2 over 2, although I ran a little out of room. So this is going to be a root 2 over 2 times a root 3 over 2 minus a negative root 2 over 2 times a 1/2. So I end up getting that this is a root 6 plus a root 2 all over 4. And that's my exact value. Now, sine of 135 minus sine of 30 is very, very different because sine of 135 was a root 2 over 2 and sine of 30 was a 1/2. So this ends up being a root 2 minus 1 all over a 2, which is not the same. See how they are not the same? Different numbers. The point in doing this example is to point out to you that you can't just distribute the sign like it's multiplication because it's not. Okay, so sine of 135 minus 30 is not the same as sine of 135 minus sine of 30. All right, so those are two different numbers. All right, let's go ahead and try another one. All right, so again, we're going to find the exact value. This is going to use that cosine of u plus v formula, right? This one is two values that I can just find right away. And actually, I'm going to go ahead and draw my little chart down here. So 225 is right here. Right, 225 is a negative root 2 over 2 and a root 2 over 2, both of them negative, sorry, my bad. And 60 is this point right here, which is a 1/2 and a root 3 over 2. All right, so this one I can actually bust out fast, so let's just bust out b right away. This is a negative root 2 over 2 minus a 1/2, or a negative root 2 minus 1 all over 2. For the other one, though, I'm going to have to use this formula cos, sine, change the sign. So it was a plus, so now it's a minus, right? So I'm going to get that this is a negative root 2 over 2 times a 1/2 minus a negative root 2 over 2 times a root 3 over 2, which means I'm going to get negative root 2 plus root 6 all over 4. And that's it. You'll notice that when you do these, you get a lot of root 6s and root 2s and over 4s. All right, so let's try it with some radians, right? Same concept, right? We just need to do it in radians instead. So if I were looking at this unit circle, right, 5 pi over 6 is right here. and 3 pi over 4 is right here. They are not conveniently super close to each other, which makes it a little harder to write. So 3 pi over 4 is at negative root 2 over 2, comma root 2 over 2, and 5 pi over 6 is at negative root 3 over 2, comma 1/2. So sine of 5 pi over 6 is a 1/2. Sine of 3 pi over 4 is a root 2 over 2, so I get that this is a 1 plus a root 2 all over a 2. So that's B. But for A, I'm going to have to use that sine of u plus v formula, right? So that's going to be sine, cos, sine, keep the sign. So I'm going to get that that's a 1/2 times a negative root 2 over 2 plus a negative root 3 over 2 times a root 2 over 2. So I think I get negative, that's a minus right there. I think I get negative root 2 minus root 6 all over 4. And again, you'll notice we get a lot of those root 2s and root 6s and over 4s. All right, last one like this. So here I'm going to have to use the cosine u minus v formula, right? These two are kind of nice because they're both in quadrant 1, although admittedly they're still pretty close together. So here's pi over, that's kind of, I missed, but they're supposed to be pi over 4. So root 2 over 2 and a root 2 over 2, right? And here's pi over 3, which is going to be a 1/2 and a root 3 over 2. So cosine of pi over 4 is a root 2 over 2 minus a 1/2, so that's a root 2 minus 1 all over 2. For this one, I'm going to have to do cos, sine. Sorry, it's kind of laggy, and then change the sign. So I'm going to get root 2 over 2 times a 1/2 plus a root 2 over 2 times a root 3 over 2. And I get that combination of some root 2s and some root 6s over a 4. And that's going to happen a lot when you do these questions. All right. Cool. So now, that's fine, right? But so in all of those, I gave you the setup. I said, hey, sine of this plus this or whatever, right? Here, I want to find 105. So what I need to do is I need to choose, or rather a negative 105, I need to choose 2 unit circle angles to add or subtract to a negative 105. There's a bunch of different options, right? There really are a ton of different choices. So you can kind of mess around with what things seem like a good option for you, right? If I try something like, you probably wouldn't think a huge number is a good option. I would probably do something like a 30 minus a 135, because those are both, so those are pretty easy. That seems like an easy choice. But you could pick others, right? Like you could pick other options. So there are other ways to get a negative 105, right? You could certainly do something like, I don't know, you could do, if you did a 315, right? And what do I want? I want a 35. So, or sorry, I don't want a 35, I want a 105, right? So 210, right? So if you did something like a 210 minus the 315, right, etc. Like you could pick a bunch of different angles, right? Just giving you samples, right? You could pick different stuff. So I'm going to pick this one because it seems like the easiest. So I'm going to say that this cosine of negative 105 is the same as the cosine of a 30 minus a 135. So that's my u and that's my v, right? So cos, sorry, we're laggy, sine, and then change the sign, right? And it does help to know what those angles are. So here's 30, right? That's a root 3 over 2 comma 1/2, right? And here's 135. That's a negative root 2 over 2 comma root 2 over 2, right? So I get that this is root 3 over 2 times a negative root 2 over 2 plus a 1/2 times a root 2 over 2. So I get negative root 6 plus root 2 all over 4. And again, not a shock, we keep seeing those root 6s and root 2s over 4 because that's kind of what's happening is we're using the 1/2s and the root 3 over 2s and the root 2 over 2s. So 75, same thing, you pick any two angles, right? So my brain says, hey, this is probably 30 plus 45, right? But you could also do something like, I don't know, you could, if you wanted, maybe do a 135 minus a 60, or like, etc., right? Like you pick, like there's a ton of options. I'm going to pick this one, right? So this is the sine of 30 degrees plus 45 degrees. So that's a u plus v. So sine, cos, sine, and then keep the sign. So again, useful to know that 30 degrees, right, is here. So that's root 3 over 2 comma 1/2, right? And 45 degrees is root 2 over 2 and root 2 over 2. Right? So I'm going to get that this is 1/2 times root 2 over 2 plus root 3 over 2 times root 2 over 2. So I get root 2 plus root 6 all over 2. Or over 4, my bad. 4, because 2 times 2 is 4. All right, there we go. All right. Okay, so the ones with the radians are a little bit harder because I get that it's not super duper duper fun. But the trick here, right, is that since it's pi over 12, right, what you basically want to do is you want to pick, so you want to pick some pi over 12s that subtract to 1, right? So actually, you don't even need to pick pi over 12. So you need to pick numbers. You need to pick a number that subtracts to 1. So pick numbers that subtract to 1, and the numbers all cancel with 12. So for instance, right, I don't want to pick 5 and 4 because, so like for instance, what I mean by cancel with 12 is you don't want to pick 5 minus 4 because 5/12 doesn't simplify, right? Like 5/12, like that's bad, okay? But you could pick 4/12 and 3/12. So what I mean by that is if you pick 4/12 minus 3/12, that would give you that 1/12, right? And because 4/12 and 3/12 simplify, right, 4 pi over 12 minus 3 pi over 12 would give you your pi over 12, but that's actually a pi over 3 minus pi over 4, which are both on the unit circle. Right? Now the other option, if you hate this, if you look at this and you're like, Hogan, I would never have come up with that, you could change this to degrees. But so I'm going to go ahead and say that this sine of pi over 12 is the same as the sine of pi over 3 minus pi over 4. So that's my u minus v. So we're going to get sine, cos, sine, and then keep the sign. So I'm hoping we're getting the gist of how we find what sine of pi over 3 is and cosine of pi over 4 is, right? So we're looking here and here, right? This is the 1/2 comma root 3 over 2. This one is both root 2 over 2s. You don't really want to have to write this down every time. Like as you get better at this, you're hoping that it doesn't, you're just kind of wasting your time if you have to write it down. You kind of just want to know it. So this is a root 6 minus a root 2 all over 4. And again, sorry, the computer is laggy. Okay, so same argument with the 17 pi over 12. You want numbers that sum to 17 and will cancel with the 12, right? So that I get something on the unit circle. So for instance, right, you don't want to pick 5 plus 12 because 5/12, that's bad. Like that's not going to cancel, right? You don't want to pick 7 plus 10, right? So you don't want to pick 7 plus 10 because although the 10/12 would work, right, just like the 12/12 would work, the 7/12 wouldn't. So you want to pick something like 8 plus 9, right? And there are probably other options that work, right? But 8 plus 9 is the one that my brain said, oh, hey, 8 plus 9 equals 17, and 8/12 pi plus 9/12 pi would cancel. I could cancel a 4 out of those, right? And if I cancel a 4, I get 2 pi over 3, which is on the unit circle, right? That's the whole goal. And if I cancel a 3 out of here, right, I get 3 pi over 4, which is on the unit circle. So that's the whole goal, right? That's the idea. So I'm going to pick these guys, right? So I'm going to get that this is cosine of 2 pi over 3 plus 3 pi over 4. So cos, sine, change the sign, right? Now, just a reminder, right? So you want to know where 2 pi over 3 is, which is right here, right? So this is a negative 1/2 comma root 3 over 2. And you want to know where 3 pi over 4 is, which is right here, right? And that's going to be a negative root 2 over 2 and a root 2 over 2. So I'm going to get that this is negative 1/2 times negative root 2 over 2 minus root 3 over 2 times a root 2 over 2. So I'm going to get that this is root 2 minus root 6 all over 4. And that's it. All right, moving on. All right, so in this case, now I'm given the reverse of the formula, and I'm asked to recognize what these are together. Well, this is sine, cos, sine. This is the sine of u plus v, right? Keep the sign. So this is the sine of 90 degrees, which is just a 1, right? Because the sine of 90 is right here. That's just a 1. This is cos, sine, change the sign. So this is the cosine of 35 pi over 12 plus pi over 12. Well, that's the cosine of 36 pi over 12, or the cosine of 3 pi. Well, 3 pi is right here, right? Because this is 0 pi, 1 pi, 2 pi, 3 pi, right? This is also 3 pi. So that's right here, which means I get a negative 1, okay? Okay, so for our last problem, we can do the same idea. Here we have the pattern and we're kind of reversing it, right? So I see this is cos, sine. So I say, oh, that's a cosine, right? It's a cosine, and then I'm supposed to change the sign. So this is going to be a 235 minus 10, right? So what we want here is the cosine of 225, right? Well, that's the pi over 4 that's down here in quadrant 3. So that's going to be a negative root 2 over 2, right? Because it's negative root 2 over 2 comma negative root 2 over 2, and we want the x coordinate. So that's my answer. Same thing here, right? I see that I have a sine, cos, and a cosine. That means it's got to be a sine. And for the sine, I keep the sign, right? So it'll stay as a minus, which means I want the sine of 4 pi over 12, or the sine of pi over 3. Well, that's right here, right? And that's going to be a root 3 over 2, right? Because this point is a 1/2 comma root 3 over 2, and the sign is the y value. And that's it for this video.